Greetings to everyone. Myself, Dr. M. Harivanan, working as an associate professor in Department of Civil Engineering in Mari Lakshman Reddy Institute of Technology and Management. It is an autonomous institution which is located at Dindukal, Hyderabad. I am handling the subject of surveying and geomatics to the second year civil engineering students. Today we are going to discuss about measurement of horizontal angle by repetition method and reiteration method, and measurement of vertical angle using theodolite surveying. Okay, let us move on to the topic. So we already know in our theodolite we are having horizontal circle as well as vertical circle. So in horizontal circle we are having vernier A and vernier B. Corresponding to that we can do the measurement of 0 to 360 degree. Okay, so this is used to measure the horizontal angle. Okay, by seeing the object we can measure. Now there are two methodology is available to get the horizontal angle. Those methodologies are, one is repetition method, another one is reiteration method. In this repetition method is the method is used to get the horizontal angle very accurately between the two objects. Okay, but reiteration method, the name itself, it is we know that the iteration method, so we can get the accuracy is somehow less, okay, when compared to repetition method, but we can able to get the readings of object for whatever in between that is 0 to 360 degree we can measure it. Okay, that is the advantage of reiteration method. Okay, so now we are going to discuss about these two methodologies in detail, how to calculate the horizontal angle using theodolite by repetition method and reiteration method. So first one is repetition method. This method is very accurate method in the work. In this method the same angle is added several times mechanically, and the correct value of the angle is obtained by dividing the accumulated reading by the number of repetitions. Okay, so the number of repetitions used in this method is normally 6. The 3 is with respect to face left observation, another 3 is with respect to face right observation. Okay, by taking an average reading we can get the horizontal angle between the two objects. In this way the angles can be measured to a finer degree of accuracy than that the obtainable with the least count of the vernier. So here this is the instrument station point, and the point A and B are the objects. So we need the angle between these two objects. Okay, now that we are going to find out with the help of repetition method. If the angle between the objects from the instrument, if I am going to take it as theta 1, okay, then if I am going to take the value of theta 1, and this can be taken with respect to face left observation by 3 times. Okay, so that I am going to observe theta 1, theta 2 and theta 3. Okay, now so by cumulating or by adding this reading I am going to divide it by the number of repetitions, so that I am getting the exact value of theta. This is with respect to face left observation. Similarly, after changing the face, that is face right observation, again I am going to view the object from A to B, that is the angle from A to B. Okay, so that I am getting further angle with respect to face right observation. That also I am going to take with 3 times. Okay, now so the whatever the reading I got finally, that reading divided by number of repetitions, if I am going to give, I can able to get the value of angle. So face left observation and face right observation I am having. Okay, now by taking average between these two readings, I can get the horizontal angle between the object. Okay, now that is a very accuracy, almost I am doing 6 times. Okay, so that I am getting the answers very accurately by this method. Now what are all the instrument we need to do the repetition method? Okay, theodolite we need, tripod we need. Okay, and whatever the object we are having in the field, that we have to get it. Okay, these are all the instruments. Okay, theodolite and tripod is the instrument used to do the repetition method. Now let us move on to the procedure, how to do the repetition method. Okay, first we have to place the instrument at instrument station point. Okay, so that we have to do centering process. By means of centering process, the instrument optical center and the ground point has to be oriented exactly. Likewise, we have to fix our tripod, and over that our instrument should be placed. Next, after doing all the temporary adjustments such as setting up, leveling up and elimination of parallax, okay, now we have to focus the point A, so that the lower clamp and the upper clamp should be in the loosened position, and the readings in the vernier A should be in 0 degree, 0 minutes and 00 seconds. So vernier A is 0 degree, 0 minutes and 0 seconds. So I have to bisect exactly to the point of A. Okay. Next, what I have to do, I have to tighten my lower clamp screw and I have to release my upper clamp screw. Okay, now so that I can able to rotate my instrument. Okay, now by changing the readings. Okay, now in the vernier A and B. So now I can able to rotate my instrument in the horizontal plane. Okay, so that the readings gets changed from 0 degree to some other values. Okay, now so now I have to focus the point B and exactly I have to bisect it. Okay, now after that I have to tighten the upper clamp screw. Now I have to see the vernier A and vernier B readings. So in vernier A I have to note down degree, minutes and seconds. Okay, but in vernier B I can take it only minutes and seconds. Okay, so for example in vernier A I am getting some 60 degree, 0 minutes and 00 seconds. Okay, that I have to list out in the table like this. So here, so my instruments at point O, side to A, okay, side to point A to B, okay, so side to B, so the angle value is 60 degree, 0 minutes, 00 seconds. Now in vernier B I said that we have to take only minutes and seconds. So in the minutes it is 0 minutes and in the seconds I can get only 00. So most probably the value of A and B, okay, no, doesn't change. Whatever the values we are getting in the point A, vernier A, same we can get it in the vernier B. Okay, so the mean angle becomes 60 degree. Okay, now I already said the upper clamp screw has been tightened well. Now we have to release our lower clamp screw, okay, now, so that the instrument, okay, we can able to rotate in the horizontal plane without changing of the vernier scale readings, okay, now, so that after rotating the instrument we have to bisect the point A. At the time the angle is 60 degree here. Okay, now we have to tighten the lower clamp screw and release the upper clamp screw, so that we can rotate our instrument by changing the reading vernier scale itself, so that 60 degree we can change it when we are rotating the telescope, okay, now that time we have to bisect the point B exactly, okay, now, so that we have to tighten the upper clamp screw, okay, and we have to note down the readings of vernier A and vernier B, so that the vernier readings is becomes 120 degree right now. Since we are cumulating the readings, okay, so we have to note down here. So side to point B. So now the angle is 120. 120 degrees, 0 minutes, 0 seconds. So here also 0 minutes, 0 seconds. So that the mean angle becomes 120 degree. Okay. Now the included angle between these two values becomes the difference between 120 degree to 60 degree, so that it will comes as 60 degree as the included angle. Okay. Now once again we have to go to the procedure. Okay. Now we have to loosen our lower clamp screw, so that the upper clamp screw should be in the tight condition, okay, now, so now we can able to rotate our instrument in the horizontal plane without change of the readings in the vernier scale, okay, now, so that we have to bisect the point A, and corresponding to the point A the value of vernier reading is 120 degree right now, okay. Now once again we have to tighten the lower clamp screw and loosen the upper clamp screw, so that we can able to rotate in the horizontal plane. So now we have to focus and bisect the point B, and we have to read the vernier scales A and B readings, so that the reading becomes 180 degree right now. So that the reading is 180 degree right now. Okay, so that we are going to focus at point B. Our reading becomes 180 degree. Okay, so we have to write all the minutes and seconds as well as 0 degree is 0 minutes and 180 degree is the value. Now the included angle becomes, okay, so 180 degree minus 120 degree, it becomes 60 degree, okay. And here we are going to take same value, whatever it is, since 0 degree to 60 degree, okay. So now this is the included angle, okay. now with respect to face left observation, what is the value of included angle? Okay, now so 180 degree, that is we have taken at last, okay, our angle theta becomes 180 degree divided by number of repetitions, 1 2 3 times we have done, so that divided by 3 if I am going to give, I can get 60 degree. So this is with respect to face left observation. Okay. Similarly, the same procedure I have to done for face right observation, so that I can get another value of theta same as 60 degree. Okay. So by taking average between these two readings, I can get 60 degree is the final value of included angle. So this is how I am going to do the calculation of horizontal angle using repetition method. So we have done with the help of face left observation. Similarly, face right. So transit the theodolite telescope first. After that, swing the instrument so that we can get face right observation. Okay, face right. The vertical circle becomes in the right side of the observer. After that, whatever the procedure I have set in to calculate the angle, same has to be done. Okay, now so that we can get the face right observation. Okay, so after getting the face right observation, by taking the average reading, we can get the horizontal angle. So that here it is 3 times, here it is 3 times, so that 6 times we have done to calculate the horizontal angle, so that we can, whatever the angle we are going to get, that in an accurate value.